All right, and so welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. Again, if you're tuning in for the first time, thank you so much for watching. We're going through this session of going through popular math questions and chemistry questions compiled by OneClass and sent in by students such as yourselves. So these topics that range from basically pre-algebra all the way to pre-calculus, and if you're living in Ontario, it's from basically grade 9 math all the way to grade 12 calculus. And in chemistry, we're doing questions covering topics from grade 11 chemistry all the way to organic chemistry in university. So these questions have been sent in by you folks at home, and what we're doing at OneClass is we are compiling these live streams for us to answer these questions and to verify solutions. Again, my name is Joey. I come from a background of being a secondary school educator. I'm qualified to teach chemistry and science in secondary school, and also I hope to be qualified also in mathematics starting September as well. So without further ado, let's get started with problems for today. Again, I chose these problems. These problems for the next hour is going to cover mostly some pre-algebra, algebra 1, and geometry questions. So basically from grade 9 to grade 10 math. So without further ado, let's get started on these problems here. Okay, so we have this problem. This is problem 1, question 1, and it states that it's asking us which equation can be used to find the measure of angle BAC. So let me just take out my tablet real quick. Which equation can be used to find the measure of angle BAC? So let me write this down. Which equation can be used to find the measure of angle? This is BAC. And we're given this triangle here, right? We're given this, so let me draw this out for you. And we have 4 choices. So let me just draw it out real quick. So this is our triangle here. It's, and I'm assuming this is a right triangle, but I don't think they have this here, but I'm pretty sure it's a right triangle here. It's a right triangle here. So they have 5, this is a 12 and a 13. And they're asking which equation here. So they give us four kind of equations here, and they're asking us which measure to find the angle BAC. So BAC would be here x here. So which trigonometric ratio do we have to use? So take a moment to think about this problem here. If you're in the chat, again, wave high and maybe give me the solution to this answer here. What do you think the solution is? And we'll take it up in about a minute or so. So what we have here is what we have here is the angle BAC, and it's denoted by this angle x here. So so this is kind of our focus here, this x here. And what we're doing is we're finding a trigonometric ratio to solve for this angle, right? So let's look up multiple choice 1. This is the inverse of cos of 5 over 13. So inverse cos of 5 over 13. So in this problem, they did, so this is inverse cos of 5 over 13, which means if we took cos and placed it to the other side, and this would equal x, right? So let me do x equals cos, the inverse of cos, 5 over 13. So if I took cos and put it back to the left side here, I would get cos x equals 5 over 13, right? Equals 5 over 13. And we know our trigonometric ratios here. We know it's SOHCAHTOA, right? SOHCAHTOA. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So with this here, we have, this would have been adjacent over hypotenuse, right? Which here, in this case, is our answer, right? By verifying 1, this is the correct answer. Adjacent to x is 5 here. Remember, 12 is opposite here, adjacent here, over hypotenuse, which is 13. So this A here is correct, right? A here is a trigonometric ratio that shows this, denotes this angle, right? So A here means it's correct. Whatever cos -1 inverse cos of 5 over 13, that's correct. So question A is here is the correct answer. Let me just verify that B and C and D are wrong. So we have inverse of sine of 5 over 13 equals x. If I took sine and placed it to the other side, I would get 5 over 13 equals sine x. And as you can see, remember, sine x is opposite, or sorry, it's it's opposite over hypotenuse. Opposite here is 12 over 13, not 5 over 13. So this here is the wrong answer, because this here is wrong, because this is supposed to equal 12 over 13, right? The opposite of x here. We can also look at C. So C states that inverse of tan equals 12 over 13 equals x. Again, if I move tangent to the other side, I'm going to get 12 over 13 equals tangent of x. And as you can see, tangent of x, again, is opposite over adjacent, right? Opposite is 12, adjacent is 5, which means this here is my wrong answer as well, right? I should have 12 over 5 as tangent of x. So this here is wrong. Tan of x actually equals 12 over 5, right? Remember, opposite over adjacent here, so that's wrong. And let me just double check D for you. So D here states that cos -1 equals 12 over 13. Cos -1 of 12 over 13 equals x. If I move cos to the other side, I would get 12 over 13 equals cos x. And as you can see, cos x here is adjacent over our hypotenuse, 5 over 13, and not 12 over 13 here. This would have been opposite. This is sine of x here, opposite over hypotenuse. So this here is wrong, because cos x equals 5 over 13. So in this case, A is our correct answer here. So let me just box that, which means A here is our correct answer. Cos -1x, the inverse of cos equals 5 over 13, which means A here is our correct answer. So let's check the solution. Option A is correct, so they got that right. The right triangle is given by ABC, yeah, which is this angle here. They showed side lengths here. So cosine is defined by the length of the base, the adjacent, divided by the length of the hypotenuse. That's good. So they defined cosine, sine, and tangent. So that's good. Remember, cosine is adjacent over hypotenuse, sine is opposite, or the length of the perpendicular. Remember, this is the perpendicular over the length of the hypotenuse, and tangent is length as the opposite over the adjacent here. So for BAC, BC is the perpendicular, so it's 12. AB is the adjacent, which is 5, and AC is the hypotenuse here. So let me give you the letters here. So it's A, B, and C. Oh, sorry, I'm still in box mode. Here's A, this here is B, and this here is C, right? So remember, BC here is the opposite here. AB is the adjacent, and AC is the hypotenuse, which means, and they verified all of this stuff as well. So cos, which means A here is correct. Cos of BAC is 5 over 13, right? And that here is correct. And then they verified sine, it actually equals 12 over 13, like so. Tangent, they did 12 over 5, like so. So therefore, all of these other solutions are false. So this here is the correct answer. So great solution and analysis. So this solution is correct. All right, let's look at question 2. Question 2 is pre-algebra questions, asking us what's 250 divided by 3. So this is kind of a very, very simple problem. So let me kind of breeze through this problem. What is 250 divided by 3? I'm assuming you don't get a calculator for this, so because in reality we would just plug this into a calculator, right? So what we have to do is we have to do a long division method, right? It's a 250 divided by 3. Divided means that here is division, right? we are doing the operation of division. So we have 250, which here is the dividend. So dividend goes into this, inside this bracket kind of here, and divisor is 3, right? And we're trying to find the answer, which is the quotient. So how do we do long division? Let's throw it back to like grade 6 or something like that. Again, 3 times what number is closest to 25 without going over? 3 times 8 is 24, right? And that's, I can't go over. I can't do 3 times 9 because that's 27, which goes over. So I would do 3 times 8 here. I would multiply 8 times 3 here equals 24. And I would take the difference of these two numbers, right? I would subtract 25 by 24, and I would get 1. I would bring down the 0. Now we're going to repeat this process, right? 3 times what equals 10 without going over. The closest number here is 3, right? 3 times 3 is here, right? 3 times 3 here equals 9, minus that, 10 minus 9 equals 1, which means I have a remainder of 1, right? Nothing else to bring down here. So my answer here is 83, and then if I have a remainder, it's 1 over our divisor, right? So it's 83 and 1/3, or you can say, in decimals, if you want it would be 83. If I want to just change 1/3 to decimals, 83.3, and then the bar, right? 3 is a repeating number. So this here is the correct answer, 83.3 bar, or you could say 83 and 1/3. This here is our correct answer. So I'm going to see what they did here in the division. Yeah, they did that. They did long division. That's good. So they did the exact same thing. And the quotient is 83.3 bar, or you can say 83 is 1/3. So this here solution is correct. Great solution and analysis. So a very, very easy problem for a question 2, which is always good. Okay, so it says convert 0.8333 as a fraction. Okay. So let me do this. So we're doing a lot of conversions today between decimals and fractions. I find a lot of students have trouble. They shy away from fractions and fractions a lot because they don't like this process of division. So this is convert. This is 0.8333 as a fraction. So we're converting this to a fraction, right? So what we're doing here is, remember, 0.833 can be represented by simply dividing this number, whatever's in the decimal, by its decimals go by 10, right? So if you look at something like this, the first decimal place here, I'm dividing by the number by 10. This here is by 100. This here by is 1,000. 1,000, and this here is 10,000, right? Remember, decimals work in terms of a decimals work in a factor of 10. So what we can do is we can say that 0.8333 equals 8,333 divided by 10,000, right? So that's what we have here. We divided it into, this is now a fraction, right? 8,333 divided by 10 is our fraction, right? And what we can do with this fraction here, we have 8,333, which I'm not sure if that's a prime number. Let me check. 8 times 3 is 8 plus 3 is 11, plus 3 is 14, plus 3 is 17. Yeah, I'm pretty sure this is a a prime number. So I can't divide. There's nothing I can divide between these two numbers to simplify or reduce this fraction. But what I can do is, let me just check my calculator for a sec. Yeah, I can't really do much with this with this fraction here. But what I do know is that I know there's kind of a list of fractions or decimals that I've kind of memorized throughout math. So what that means is, like, if I have like 1/2 here, I know 1/2 equals 0.5, right? That's a very common decimal here. Or 1/3 would equal 0.3 bar, where bar means just a repeating number. 1/4 is 0.25. 1/6 is 0.16 bar. and so on. So 1/6 also has 5/6 is also 0.83 bar as well. And I know this because I can divide 6 by divide 5 over 6. If I do this long division, if I extend the zeros, I would get the answer of 0.833 bar. So in doing so, because I have something that's very, very close to 5/6 here, it basically like 8,333 over 10,000 is our answer. But if this was 0.83 bar, I could safely say that I could actually reduce these two numbers to 5/6, and that here would be my answer here. So let me just check what they did in terms of their solution. So it says now the numerator and denominator are co-prime numbers, thus is the fraction form of the given decimal expression. So this here they just ended it off by saying this, but basically I'm saying that if I'm gonna prove that this here can equal 5/6 if I were to extend my my fractions here, and if I did 6 divided by 5 and then did 0.000, you can do, if I do this calculation here, again, if I do this division here, 6 times what number is 50? Closest to 50 is 8. I would have 48 minus 2. I would bring down the 0 here. And we get, this is now 3. 20 minus 18 is 0 again. And as you can see, this repeats, right? This process repeats. I still get the remainder of 2. I drag down 0. It gets 3, 3, 3, 3, and so on and so forth. So I can say that the 3 here is repeating. So this here is a very, very close approximate to this. But again, because I don't have 0.83 bar as my fraction, I can safely say that this here is my correct answer. This fraction is my correct answer. But if it was if this 3 repeated forever, then this here would be my correct answer for the solution. So this here, I'm going to say great solution and analysis. All right, let's do number 4. I'm actually pretty on time today, which is nice. It's only been 17 minutes. I think we got in pretty easy questions today. Let's do this for, whoops. So it's saying in the parallelogram W, X, Y, and Z, what is C, Y, right? So in parallelogram W, X, Y, Z, or Z, what is CY? And then they have a parallelogram here. I don't know if I can draw this nicely, but I will try my best. That's not very good. All right, that's the best I'm gonna do. And this is the point from the center, C, and this is Y. This here is W, and it's saying from here to here is x plus 4. X plus 4, and from here to here is 2x minus 7. It's kind of hard to see actually. So let me draw some arrows here. So this here is x plus 4 feet, and this here is 2x minus 7 feet. So what is CY is our question here. So take a moment to think about this question. In the parallelogram W, X, Y, and Z, what is CY? How would you determine what CY would be? Remember, you have to think about what defines a parallelogram in terms of lengths, in terms of angles. What defines a parallelogram? Because I'll give you a hint here. A parallelogram has opposite sides that are parallel. So these two sides are parallel, and basically it's a parallelogram has right angles that are all has angles that are, which are not right angles, right? So if I have right angles here and here, it'd be a rectangle. So remember, parallelograms here are the opposite sides are parallel, and opposite sides are also congruent. So they have equal length as well. The diagonals also bisect each other, right? So diagonals also bisect each other at this point here, at C here. So how would we solve for this problem? How would I find the length of this parallelogram? Well, let's work this problem. If I know that my sides bisect each other, it means that I know that this length here equals this length here, right? WC has to equal CY here, right? To make this assumption work, right? So if I say that WC equals CY, then I can make the expression I have x plus 4 equals, or I don't need the brackets actually. So it says here x plus 4 equals, this is 2x minus 7, right? What I can do is then I can simply just, I'll rearrange for this for x and sub x back into our equation, right? To see which value x satisfies for this equation here. So let's do it, right? I can collect my like terms, so I can move 2x to my other side, my left side here. So I have x minus 2x, right? Which here would be negative x. And if I move plus 4 to the other side, I would have negative 4 minus 4. So I have negative x equals negative 4 minus 4 would give me negative 11. And the x would simply, if I divide both sides by negative 1, I would get 11 here. So x equals 11. And what I can do is I can sub x equals 11 back into my equation for, I want cy, right, for this here. So I have 2x minus 7 is equals to cy, right? So cy equals 2x minus 7, and then cy equals 2 times 11 minus 7. So 2 times 11 is 22 minus 7. This here equals 14. So, 15. And this here is my correct answer for cy here. What's cy? Cy here is 15 feet. So let's look at the solution here. Since the digital diagonals of parallelogram bisect each other, therefore C is the midpoint, which means that I know that from here WC equals CY, and that's what I did this here. They did the exact same thing. They took all their variables, they rearranged this equation to solve for x here. X equals 11, which is good, and therefore they plugged this back into the equation, and they got x here equals, or CY here equals 15 feet. So this here is correct. I don't really like how they didn't really show how they rearranged it, whereas I kind of showed my work here. So I'm going to say this is a good solution, or great solution, but show work for the equation 2x. Actually, they did show work actually. From here to here they did show work. So actually let me just not put that. I'll just say great solution and analysis. Solution here is correct. Okay, so that's number 4. Let's do number 5. So number 5 is asking, what is the square root of 160? What is the square root of 160? So take a moment to think about this problem. What is the square root of 160? So again, I'm gonna do this in exact values because I'm assuming that's what they want. And not really decimal. I could always get a root of 160 if I just plugged it into a calculator. But I'm assuming what they want is an exact value. So I'm gonna assume here that they want an exact value of the square root of 160 here. So square root of 160, how would I do this problem here? So if I drew this out, and I would just say this is the square root of 160, how would I break this radical down for me to get square roots that I can actually solve for? So how I usually do this question is I were to say that root 60, I would kind of divide the root here, or whatever's inside the root, by 2, right? Because this is an even number, right? So if I divide by 2, I would get kind of 2 times, this is whatever 2 divided by, what 160 divided by 2 is, which is 2 root 80, right? And as you can see here, I can do this problem again, right? I can take another root 2 out and then basically diminish this value. I'm going to see if I can find some sort of common value here, right? So again, I can take root 2 here, or have root 2 here times. I'm going to divide root 80 by root 2 again. So I'm going to take it out. So I'm going to have root 2 again times 80 divided by 2. Here is root 40. So I have root 2 times root 40 here. Well, I know that root 2 and root 2 cancel out, right? Root 2, these square roots just cancel out. Root 2 times root 2 is simply just 2, right? So this here equals 2 root 40, or 2 times root 40. Doesn't matter how you write it. And again, I can do the exact same thing for this 40 here, right? I see that 40 here can be divided into 2. So you can say this is 2 times, I'll say root 2 again, times root 20 now in this case. 40 divided by 2 is 20. And then again, I can do the exact same thing with root 20. I can divide it by 2, right? So it equals 2 times root 2 times another root 2 times root 10, right? And now you can see that I have root 2 and root 2, the square roots cancel out. So I have this here equals 2 times 2 times root 10. 2 times 2 equals 4. So I have 4 times root 10, which here is my this here is my answer, right? Because what I can't do is I can't separate 10 into, I could divide 2 into, you could divide 10 into 2 parts and say that this would also equal 4 times root 2 times, again, root 5, because I have 10 divided by 2 is root 5. But we don't really do our radicals like this. We don't really do 4 root 2 root 5. That doesn't really make sense. It would just simply be root 10. It's usually an integer and 1 square root as our exact value. So in this case, this here is our correct answer. So 4 root 10 is our correct answer in terms of exact values, which I'm assuming that's what they're doing here. So say, what is the square root of 160? So they're doing a Methodas shown value. They're doing a Methodas kind of method here, where they take there's basically solving for square roots. They're computing what a square root is. So let's see what they did here. So they took 160 and then they divided it by 12 here. They're doing long division. So 12 times 12 is 144. You get a remainder of 16 here. And since, okay, let me just read. So take a value such that the square of it is less than 160 and proceed like long division. So square of 12 is 144. Also derive the next divisor value as the product of the first divisor and 2. So this here becomes 24. Here, 12 times 2 is 24. And then now take the term as 0 and use decimal in the quotient to solve it further by taking 6, since 246 times 6 is 1,476, right? So again, they're doing, they're bringing down, they have imaginary zeros, so they're making it 1,600 here, and then 2,446 times 6 here equals, that's the closest number to 1,600, right? And they're adding 6 into this makes a new divisor, and you can simply repeat this process to get another decimal place. So this here says that it's the square root is 12.64, which is the correct answer here. Again, you can do the exact same thing with 4 root 10, and you would have gotten the same answer here, right? If I were to say that, if I did the Methodas value for root 10 here, I would get something, I would get a value that is very, very similar to whatever 12.64 divided by 3 is. So 12.64 divided by 4 is like 3.16. So if I did that, if I took the value of, if I did the Methodas value for root 10, so let's say that I have, oh, sorry, this is still boxes, I keep forgetting. I have root 10 here. And what I would have to do is I would have to do, whatever the divisor here in this case would be whatever the square is closest number, right? So you get, in this case it would be 3, right? 3 squared here is 9, right? And then I can do and I have a 1 here. 10 minus 9 here is 1. And then I could add imaginary 0 here. And then my next divisor in this case would have been the product of the first divisor and 2, right? So 3 times 2 here is 6, right? 6 here. And I can do the same division, right? 6 times what is closest to 10, 6 times 1 is the closest to 10, right? I can add my decimal here, and I have 6 minus that, 10 minus 6 here is 4, and I can add another 0, and then proceed like so, right? So, and then again, I have 6 and 40 again. I can say 3.16. 6 here, 6 times 6 is 36. And then you realize that this here repeats itself, right? Because I can bring down the 0 again, and I would simply get, I would keep getting 6 on top. So if it's the same thing as saying that it's 4 times 3.16, right? If I assume that root 10 here equals 3.16, therefore I have 4 times 3.16, and this here would give me a value of 12.64. Sorry, 12.64, which is my answer for which is the same answer as root 160 here. So again, there's two ways to approach this. You can use exact values, or you can use the method-ask method. And again, it's up to you. It's basically up to you in terms of how to commute this and what the question is asking. If they want it in decimals, then you have to do this method. If they want it in exact values, which usually is what teachers want, then you kind of have to simplify the radical like so. So I'm going to say this question is correct. Great answer and analysis. Solution here is correct. All right. This was question 5. Let's do 6 now. So here, if the isosceles triangle ABC has a vertex, or has a 130-degree angle at vertex A, which statement must be true? So let me just draw. I don't want to write out the questions. Let me just draw the triangle here, and we'll go through each of these statements together. I wish they had a triangle function. Okay, so this here is A, and this is 130 degrees. This here is B, and this here is C. So it's saying if the isosceles triangle, what does isosceles mean? Isosceles triangle means that 2 of my sides have equal lengths, right? So isosceles means that 2 side lengths are equal. So I can say this side length and this side length are equal to each other, right? So that's good. If those 2 side lengths are equal, then the two angles here must be equal as well, right? This here has to equal angle B has to equal angle C, right? If both sides are equal, right? It makes sense because the lengths are equal, right? So so this here, I can say that this is x, but this is also x, right? And then I can use the sum of interior angles to prove these guys here. So I can say that sum of interior angles of a triangle is 180 degrees. Equals, I have a 130 degrees already here. That's already my first angle. Plus, I'm solving for x, plus x equals 180, right? I have 180 equals 130 degrees plus 2x plus x here is 2x. 130, if I move this over, I have 180 minus 130, which equals 50 degrees, equals 2x. And then I can simply just divide both sides by 2 to get x here equals 25 degrees on both both B and C, right? So here equals 25. So this case, x here is 25 degrees. This is 25 degrees. So we that's all the information we're given with this problem, right? I know that 2 side lengths are equal, and I'm solved for all my angles. So let's look at here. Statement A says angle B equals 15 and angle C equals 35. In this case, they're both equals 25, so answer A is wrong. Option A is wrong. Option B, A plus B is 155 degrees. 130 plus 125 here. Let me just verify this. Angle A plus angle B equals 155. Angle A is 130 plus B is 25 equals 155. So this here is correct, right? 155 equals 155. Option B here is correct. Let me do, so if I know option B is correct, C and D must be wrong. So angle B here is 25, angle C here is 25. 25 plus 25 equals 50, right? So this does not equal 60 here. And then finally, angle B and angle C equals 20 and 30. Obviously, we know it's 25, which means here B is my correct answer in this solution. B here is the correct solution in this question here. So let's see what they solved here. Given the triangle, angle is 130 and angle AB equals angle AC. Good, because we know that angle B is equal to angle C, because I know that the sine lengths are equal, right? So they use the property of the isosceles triangle. Perfect. They use the exact algebraic expressions to solve for x equals 25, but they instead of they use x, they use angle B, which is totally fine. Therefore, option A is false, option B is true, option C is false, and option D is false. So this here is great solution and analysis. Solution here is correct. Now it's question 6. I feel like we've been getting pretty easy problems today. That's pretty good. This is question 7, another parallelogram. So it says, it's asking us, what is the value of x in the parallelogram QRST. Let me draw this out for you as well. So QRST. This is a really bad parallelogram, but it will have to do for this one. This is Q, this is R, this is S, and this is T. And I have a midpoint, or the bisecting lines intersect, and this is O. And it's saying that I have all these lengths, right? This is 8, this is 12, this is 3x, this is 2x here, right? So what is the value of x here? So again, we kind of did a very, very similar problem. Let me just zoom out and show you our similar problem here. So remember, our similar problem is this one here, right? In parallelogram, w, x, y, and z, what is the value of c and y? And we knew that from the property that cy here equals wc, right? We know that because the length between wc and c to y is exactly the same. So what I could do is I can do the exact same for this question, right? From q to o and from o to s is the same length. From t to o and from o to r is also the same length here. So let me justify, and let me write this down for us here. So again, if I know this, I know that from Q to O, Q to O has to equal O to S, right? O to S here. Q to O has to equal O to S, and I know that T to O has to equal O to R, right? So from T to O equals O to R, right? So now I can just simply plug in my algebraic expressions, right? So Q to O here is 8. Has a length of 8, and O to S has a value of 2x here. And so then I can solve for this algebraic equation, right? 2x equals 8. I can simply divide both sides by 2, and then we get x here equals 4, right? So that here is our answer, and we know that B is our answer here. But what we can do is we can verify T to O equals O to R, right? So T to O here is 3x. O to R here is 12, right? 12. And again, I can divide both sides by 3 to get rid of the 3 on the left side. So dividing that 12 by 3 here gives us 4 as well. So x equals 4, x equals 4. The world is nice. B here is our correct answer, because I know that these lengths have to be equal for me to have a parallelogram, right? Remember, my bisecting lines here, the same length from one side length or one corner to the middle or to the center of the parallelogram has to equal from the middle point to the other corner as well. So using that property of a parallelogram, I was able to solve for x here. So in this case, B here is correct, and they did diagonals are intersecting at point 0, which is great. Length of that is 8, so they basically just redrew it here, and they're saying 8 equals 2x, 12 here equals 3x. So they did this here was the exact same thing as what I wrote down, right? QO equals OS and TO equals OR, and they wrote it in algebraic form, right? 8 equals 2x and 12 equals 3x, which means x equals 4, right? For both of them. Therefore, A here, or B here is our solution. So this here is great solution and analysis. So our solution here is correct. Nice. So this is 7. That's good. Let's do number 8. So another radical question. How do you find the square root of 85 here? How do you find the value of, or how do you find the square root? Square root of 85. So again, we have 85, right? Square root of 85 here. And again, I'm assuming what they're doing is they are they're showing us the simplest radical form, so like what the exact value is. So if I'm given 85 here, what the only thing is divisible by, it's divisible by 5, right? It's not an even number, so we can't divide by 2. It's not divisible by 3 because 8 plus 5 equals 13, and that's not divisible by 3. So in this case, I'm divided by 5. So I would get root 5 times, what's 85 divided by 5? I'm just going to simply just use my calculator here. 85 divided by 5 here is root 17. So I have 5 and 17, and they're both prime numbers in this case, which means I actually can't simplify root 85 into a simplified radical form. So in this case, root 85 is all we have, because I can't have, remember, in simplified radical form, I have an integer, and I also have a square root, right? So I can't write, it does not equal, it equals this, but it doesn't, like, this doesn't like tell me anything about this problem here. So it's just root 5 times root 17, which is also root 85, right? So again, it doesn't show me anything here. But what I can do is I could use the method-ass solution, and I'm pretty sure that's what they did with this solution here. Or actually, they didn't do the method-ass solution, so they just left it as root 85, or root 5 times root 17 here. But what we could do is, like our previous solution for the square root of 85, is what we can do is we can actually do some sort of method-ass solution, right? We can divide 85, and we can find whatever squares come out to that first. So I could actually, let me just show you briefly, but we've kind of already done this problem here. But I'll kind of show you what we're working with. So I'll just do like 2 decimal points or something like that. So we have we're gonna put 85 here. I'm looking for a square that is the closest to 85 here. 9 squared equals 81. That's closest to 85 without going over. So we should have 9 here, 9 here. 9 times 9 here is 81. 85 minus 81 here is 4. I can bring down an imaginary 0 to help us with our solution here. And then what I'm going to do is I'm going to multiply 2. I'm going to multiply 2 by the shoot, what's the word here? Divisor. Divisor is the word I'm looking for. Multiply 2 to the divisor to get 18, and I'm doing 18 times something equals 40. The closest number here is 2, right? 18 times 2 is 36. So I have a decimal place now here. 18 times 2 here is 36, and then as you can see, it kind of goes on in terms of I can bring an imaginary 0 down. Again, 18 times 40 here is again 2, and I'm only going to do 2 decimal places. So this here is 4, and so on and so forth. So approximately this here, the approximate value of root 85 is approximately 9.22. So again, you can use the method-ass solution, or you can use the exact values depending on what the question's asking here. So the solution here says root 5 times root 17, which is what I got. That's perfect. And none of the factors of 85 is a perfect square. So they just stopped there, which is totally fine. 9.22 would give me the method using the long division solution. So I'll say great solution and analysis. If I were to use long division method to find a decimal, I would get 9.22 as my solution here. So the solution here is correct. Okay, that's question 8. Let's look at 9. Oh, I think we can solve 10 problems today, which is awesome. Let's look at question 9 here. So given the angle or right triangle x, y, and z, what is the value of tangent of y? So let me draw this triangle. It was very, very, very similar to our first question of the day, actually. X, Y, Z. And we have right triangle here. This angle here is 60 as shown by the diagram. This here is a 30. And this here is a 4, right? So we have 4 here. It's asking us, what is the value of tangent y? So what was the value of tangent of y here equals, and I don't know what tangent of y again. What does that equal? That equals opposite over adjacent, right? Again, SOHCAHTOA. Again, I can write out SOHCAHTOA here. I always write out this mnemonic when I solve trigonometric problems that have a right triangle here. I have, this is opposite over adjacent, right? So opposite over adjacent. Angle y here is angle 30, right? So angle 30 equals opposite over adjacent. And in this case, I don't have my opposite, right? Again, you can say that this here is A and this here is B, right? Which means that tangent of y or tangent of 30 degrees, you can say equals O over A, right? And O over A is simply just opposite, which is A over B, right? So if I don't have these two, how do I solve for this problem? Like, what would I do, right? So what I can simply do is I can take another trigonometric ratio and solve, and using the hypotenuse to solve for this first. So I can pick anything. I can pick sine or cosine in this case. In this case, I'll pick sine, right? So I can say sine of y equals the opposite, which is A here, over our hypotenuse, right, which is 4, right? Opposite over hypotenuse, which is 4, A over 4. Sine of y here is, I know, sine 30 degrees equals A over 4. And I can plug in sine 30 into my calculator. If I do sine 30 in my calculator, I would get half. So sine 30 equals half, or half equals A over 4. I can multiply both sides by 4 to solve for A. So half times 4 equals A. In this case, A here equals 2, right? So I know now that A here equals 2. And simply now because I have, instead of 2 unknowns, now I have 1 unknown, I can solve for my problem here, right? So knowing that A here equals 2, I can rewrite this as tangent 30 degrees equals A, which is 2 over B, right? B is my unknown here. So now what I can do is I can simply I can multiply both sides by B. So I would have B times the tangent of 30 equals 2. And then what I can do is I can simply just do, or I can simplify tangent 30 first if I wanted to. Tangent 30 here equals root 3 over 3, right? So B times root 3 over 3 equals 2. And then I can simply divide both sides by root 3 over 3 to solve for B here. And if I did that, I would get 2 divided by root 3 over 3, which is simply, let me plug this in. 2 divided by root 3 over 3 is simply just 2 root 3, right? 2 root 3 would be whatever my B value is. Or if I were to change it to a to decimal, I would have gotten something. It would be approximately oh wait, am I solving for sides? Oh, I am solving. I'm not solving for sides. It's asking what the tangent y value is, which is simply just O over B, which is simply just tangent 30. Tangent 30 is just root 3 over 3. Oh, interesting. Okay, actually, I don't think that's what they want me to solve for, because I solved for both sides here, which is 2 over 3, and I used tangent 30 equals root 3 over 3 here. So let me just backtrack here, because I think I've already solved for this solution, but I think they want me to solve for B using another trigonometric ratio. So let me just erase this first. I've already gotten the correct answer, which is actually root 3 over 3, but let me just backtrack here and say that I think they want me to find out what tangent 30 equals to in terms of proportions. So tangent 30 equals, this here is A, which is 2 over B. And I can solve for B using another trigonometric ratio. I can solve it using cosine here. So if I did cosine of y equals, remember the cos of y here is the adjacent over the hypotenuse, so it's going to be b over 4 here. B over 4. And again, I can multiply both sides by, or I can figure out what cos of y is. Cos of y here is cos 30 degrees, which is b over 4. Cos 30 degrees, I believe it is root 3 over 2. So I have root 3 over 2 equals b over 4. I can multiply both sides by 4 to get 4 times root 3 over 2 equals b here. And this cancels out this here too, so it means b equals 2 over root 3. So now what I can do is I've found the trigonometric ratio that equals tangent of y, right? Because if I have b here, I can solve for, I know that b here equals 2 over 2 times root 3 here. So tangent 30 would equal this. And you would realize that this just simply equals root 3 over 3. Simply just by saying, just dividing these two out, because 2 and 2 cancel out, I get 1 over root 3. And if I rationalize this, I would get root 3 over 3 to put the radical at the top. So let's look at this. In the right triangle, we know it's equals 30 degrees. Tangent y equals 30 degrees, so it's simply just 1 over root 3. So this here is a correct solution. I approached it using a different way in terms of if we didn't know what the side lengths are, but you can just simply shove it into your calculator and still get tangent 30, right? That works as well, and you would get root 3 over 3. I just didn't know what the question was asking. I thought the question was asking what the side lengths are in order for me to solve for my trigonometric ratio, so I actually did more work in the solution than needed. But therefore, this tangent 30 equals root 3 over 3. That's my answer here. So this here is my correct solution. So root 3 over 3 here is correct. So this here is great. Solution and analysis. Sweet. And yes, I can do one last question for today. Oh, an algebra question. Here is question 10, and we will end off our video with this last question here. So this states, what is the graph of the linear inequality of 2x minus 3 is less than 12? So 2x minus 3y is less than 12. So again, what I can do to graph this inequalities, I can simply change this to a y-intercept form, right? This sign here, I can kind of treat it as equals with an exception, right? So in order for me to do that, I can simply just do, I can move x to the other side. Again, I'm isolating for my y-intercept value, right? So 2x would go on this side here. So I would have negative 3y is less than, I have 12 minus 2x, right? Here, and then I can simply divide negative 3 to both sides, right? So I have y here divided by, I can divide both sides here by negative 3. Oh, let me just draw this out first. If I divide both sides by negative 3 here, you have to be careful. Every time I divide something by negative 3, and if I have an inequality here, it flips the sign. So in this case, I have y here, instead of less than, it's going to be I have greater than, and then this would be negative 4. 12 divided by negative 3 is negative 4, and then I'll have plus 2 over 3x here. And this here is my graph for, and I can graph this as well in terms of, I can sketch a graph of this here, right? So I know my slope here is, I know my my y-intercept. So this here is, I can graph it, right? This here is x, this here is y. So again, my y-intercept here is negative 4. And then I have a slope of 2/3, right? So again, it means that I'm going up by 2, and then I'm going right by 3, right? Again, it's a positive value here. So again, I have to also solve for, in terms of, because my y has to be always greater than this algebraic expression here, right? So again, which means y here, well, let me just sketch this graph actually first. So again, I have 2 over 3. So again, I'm going 1, 2, I'm up by 2, and then right by 3. So this I'll get another point here. Actually, hold up. Let me do, this is 3, 2, and 1. This is 1, 2, and 3, 4, 5, and 6. So up by 2, right by 3, up by 2, and the left by 3 would give me some sort of graph line that kind of looks something like this. that would kind of be my line here. So again, what they did here is 0 and 4, and this here is my correct solution, right? So again, this here I plugged in like 0 and 4. Negative 4 is my y-intercept. Again, my x-intercept here is 6 and 0. And this here is going to be my graph for the solution, right? So again, my graph here actually only extends to, again, this plane, right? Because it's an inequality, right? So it actually has a boundary between these two planes, this quadrant here. So it can't extend into the next quadrant or this quadrant here, because remember, it has to still satisfy my my equation here, negative 4 plus 2 over 3x, or y has to be greater than this equation here. So this solution here is correct. Again, they drew out the plane in which they said since 0, 0 satisfies the given inequality, hence the shaded region will be the required graph, right? So this here, this graph here or this inequality shows this plane here, right? So this is good, and my line here lies on this plane, right? It lies on this plane here. So this here, again, my solution here is correct. And what they did was, they converted an inequality into an equality. That's good. And then they just plotted this graph here. So that works out as well. This here is a great solution and analysis. And again, you can always use Desmos and check your answer here. So let me just use Desmos, and I can check my graph here and state that. I don't know if I can do less than or equal, but let me try this. This is 2x minus 3y is greater or less than 12, right? And as you can see, this is kind of the shaded region that we were talking about before. Or let me do equals 12 here, and this here is the point. This here would be my point 0, 4. So again, this here would be my y-intercept, right? This here is my 0, 4 is my y-intercept, and this here is my x-intercept, 6, 0, right? So again, this here is my line, and it's the shaded region. So it actually keeps going like this, and it can't go above because again, it has to be less than 12 here, and it can't go. It does not exist in terms of the bottom region here. So this here is my line. I graphed my line like so. This here is the correct answer. So great solution analysis. So this here, I've answered 10 problems in the span of an hour, which I'm happy for. That was the goal for today. Again, if you were tuning in for the first time, again, thank you for watching. I'll be kind of streaming these videos again. I stream about from Monday to Friday for about 2 hours each day. So I stream from 10 a.m. to 11 a.m. for basically grade 9 algebra and geometric problems, and then I have another stream coming up at 12, and that was stream kind of grade 11 and grade 12 problems like that. I stream math from Monday, Wednesday, and Friday, and then stream chemistry on Tuesdays and Thursdays. So that's kind of my schedule for today. Again, if you're in the chat, thank you so much for watching. And as always, stay safe, stay healthy, and have a great day. Take care. See you, folks.